Okay, so let's do this one, and we'll jump straight to the solution. And again, you know, I'm not going to make you rederive all the Fourier transform stuff. We could just use what we've learned. To say u of xt is equal to, okay, we're going to use the D'Alembert solution. Okay, it's going to be f of x minus t times f of x minus t plus f of x plus t. So this is our f. So we'll have this. So it's going to be this minus t plus, whoops, plus is going to be this plus t. Okay, and then I need the integral part. And it's going to go from x minus t to x plus t. And we're going to be integrating this function here. Okay, our variable integration, it needs to be a dummy variable, right? So we'll call it ds. Okay. So let's see what we've got there. Okay, good. Now, the limit of the first term, whoops, is 0 as t goes, whoops, as t goes to infinity. Okay, and that's for all values of x, but in particular, if you put x equal to 0 there, we've got, you know, as t goes to infinity, we've got it to the fourth power and then minus that. So this exponent here is going to minus infinity, so e to that goes to 0, and e to that goes to 0. So we just are left with this part right there. So then lim t to infinity u of x0, probably going to do a couple of lines here, is going to be equal to this integral right here. Okay, but you know, x is equal to 0, so it's going to go 0 to, you know, t like that. Okay, well, this is, you know, this integral has exponential decay, so I'm just going to do minus infinity to positive infinity. So this is just going to be equal to this integral, but going from minus infinity to positive infinity. Actually, you know what? What I'm going to do first. Well, no, sorry. It's getting, all right. This is just the integral going from minus infinity to positive infinity. So I need to put this here. Okay, so it's going to be this integral, but going from minus infinity to positive infinity. Okay, and now what I'm going to do u sub. So I'm actually going to write this in a more convenient form. So it's going to be minus s over 10. Whoops, 10 squared. I realize I wrote a 2. Whoops, keep doing that. This is going to be more convenient for me to deal with because I'm going to do u sub here. So let u equal s over 10. Then what do we have here? du is equal to ds over 10. Okay, whoops, what did I do? Okay, so what we're going to have this, okay, so we're going to start making our changes. Okay, so u is equal to s over 10, so minus infinity over 10 is still minus infinity, and infinity over 10 is still infinity. But now what we're going to have e to the power of minus u squared, because u is equal to s over 10, so wherever I see an s over 10, I'm putting a u. And now ds is equal to 10 du, so this is going to be 10 du, and this is equal to, okay, I'm gonna factor the 10 out over here, so it's going to be 10 over 2, that's going to be 5 times this integral, but I need to get rid of the 2. And now I'm going to do something that's going to kill some of you guys. This is equal to 5. This is obviously equal to 5 times the square root of pi, where in the last step we use the well-known fact that this integral here is equal to pi, except without the 5. Equal to the square root of pi. Equals. And similar to the above, this is related to the fact that this is a Gaussian. Okay. And I mentioned in class, like, where this, why this is true. Like, why is this integral equal to the square root of pi? It's obviously, well, to me, it's not obvious by looking at it. I would not say, okay, this is definitely going to be the square root of pi. I would not expect that from this a pi would come into play at all. But you switch to polar coordinates, and then once you switch to polar coordinates, there's circles involved, and maybe that's where you're going to get the square root of pi. I mean, I know that's where you're going to get the square root of pi. I would suggest you looking this up if you don't want to know why it's true. Okay, but that is it for this one.